Hello and welcome back to Mr. Powers Teaches Algebra 2. And what are we doing today? We're taking a look at absolute value inequalities. So first off, let's take a look at something like this. Okay, how about absolute value of P is less than or equal to 4. Let's say we want to know all the solutions to a statement like this. So obviously, naturally, we want to list some values. What kind of values would work for that? Well, P is a -3. That would work because an absolute value of -3 is 3, which is less than or equal to 4. In fact, -4 would work. 3 would work. 4 would work. 2 would work. 0 would work. 1. All these values, if I plug in to P, absolute value of these are all going to be less than or equal to 4. And so fairly quickly, as we mess around with this, what we see is the solution, if I'm looking at these on a number line, is really going to be everything from -4 to 4. It's all of these values, and we'll include the ends because we have equality. All right, so this is also turning into a compound inequality. In other words, it turns into -4 is less than or equal to P is less than or equal to 4. And that's something to keep in mind. And because of that, what we can do is we can say, hey, we got these rules now, and we can just follow these rules here. Bam. Right here. These guys. And that's what we're going to use to solve absolute value inequalities, at least when we have an absolute value that is less than or equal to something. We got this rule to use, and it's very easy, very straightforward, piece of cake. All right? Let's go ahead and solve one right now really quick to show this, and then we'll go over the other situation where we have something that is greater than. An absolute value that is greater than, and see what we're going to have to do for that one. Okay, so for example, we could say let's solve absolute value of 2x minus 4 is less than 10. Let's say I want to solve that. Then I would use this right here to restate this as a compound inequality. And I would say -10 is less than 2x minus 4 is less than 10. And something, of course, worth mentioning is it's an absolute value. B over here, absolute value P is less than or equal to B or less than B. B needs to be a positive or 0, preferably some positive number. If it's not, then obviously there's no solution. If it's a negative here, absolute value can't be less than a negative, so there's no solution. So that would be silly anyway. All right? So moving on here, once we have it in this form, we solve it like we normally would, and we'd be done. No problem whatsoever. -6 less than 2x is less than 14. Divide everything by 2, and we are going to get -3 is less than x is less than 7. That would be our solution. And if we're going to graph it, well, interval notation would be -3, 7. And if we're graphing it, we would have a -3, we would have a 7, and since we don't have equality, they're open circles or parentheses, just like that. So that's how we would do that. Now, let's go ahead and talk about our other situation. That is when we have an absolute value greater than a positive number. So let's say absolute value of p, just for example, just to think about, absolute value of p is greater than or equal to 4. Now what kind of solutions work? And this time, let's just jump straight to a number line. Last time we were all the values between -4 and 4. But this time, I think probably will be the other way around. So first off, values greater than or equal to 4, those would work. So values like 5, 6, 7, all of these are greater than or equal to 4. So all of these would work. All of them going this way, for sure. Values in between -4 and 4, would they work? Absolutely not. Let's try 0. Absolute value of 0 is not greater than or equal to 4. It's less than 4. Okay, so we know all these values won't work. I invite you to try them out, see if any work. But I'll bet you all these values less than -4, like -5, -6, -8, all of these as we keep going and going, those will definitely work and make our inequality true. For instance, -8. If we had absolute value of -8, that is the same thing as 8, and 8 is greater than or equal to 4. So -8 works, as would each of these other examples. So what do we end up with? We end up with this absolute value being greater than a number, being the same as another compound inequality. In this case, -4 is greater than or equal to p, or I should say, yet p is less than or equal to -4, or p is greater than or equal to 4. And an easy way to remember on this is really this is the same here without the absolute value. And when we rewrite it the other way, flip the inequality symbol and make that positive number a negative. That'll always do it for you. And then it's always an or in between. Just like up here, where we, again, we copied p less than or equal to 4 is right here. Okay. Oops. Okay. Let me see here. Sorry. Where'd it go? Oh. There it is. P is less than or equal to 4. Okay. And include the other one, which is right here. If you look at this, is actually p greater than or equal to -4. But you smash it together like this, it's an and. Okay? Okay, so now, back to here, this implies we can do this every time we have an absolute value greater than or equal to a positive number. And so we have this rule right here. Let me go ahead and share that with you. And quickly do an example here for you guys. All right? So we got this rule. So let's use this rule in practice with another straightforward, easy example. (2x minus 3 is greater than 7. Let's do it on that one. So I have a greater than symbol, which means I'm going to use this rule here, which means I'm going to go ahead and rewrite it as an or. I'll write the 2x minus 3 is less than -7, or 2x minus 3 is greater than 7. And I'll solve this compound inequality, and I will have the solution to my absolute value inequality. So really, these are super easy. Absolute value inequalities are super easy. They're just compound inequalities with an extra step. You just got to remember these 2 rules that I posted in here. That's it. Super easy. Super easy. So, finishing this up. Once we rewrite it, it's just solving a compound inequality. It is a piece of cake. So, what do I got? 2x is less than negative 4, which means x is going to be less than negative 2. Or, so we got this, or, let's see here, add 3 to both sides on our other inequality. We'll get 2x greater than 10. That means x will have to be greater than 5. And so since it's an or, we can plot both of these on the same number line and see what it looks like. We got negative 2 over here. We have 5 on this side. We are less than negative 2, greater than 5. That's what our graph would look like. And in interval notation, if I wanted to take this, whoops, we can do better. If I want to do this and rewrite it in interval notation, it would be negative infinity. And you can look at the graph as well, right? Negative infinity to negative 2. Union, so we'll do this u, 5 to infinity. And since we don't have equality, we do not use brackets, we use parentheses for the negative 2 and the 5. And that would do it. That would be our solution. So there is a nice quick review, quick lesson on absolute value inequalities. Once again, the only thing that's new, if you're learning this for the first time, would be this rule here, okay, which I exemplified right here, and this rule here. And these are just ways to turn absolute value inequalities into compound inequalities. And that's it. That's the trick. So I hope you found this useful, and until next time, enjoy doing math.